Hi, welcome to the first video for AP Physics C Unit 6 for mechanics. This is oscillations, and in this video we're going to kind of discuss some of the basics of simple harmonic motion. And so here we're going to do a lot of the defining, and then we'll do some applications in the last two videos. And there's only going to be 3 videos for this unit. One thing to note, that periodic motion is essentially repetitive motion. So it's a motion that is going to repeat itself. And when we talk about simple harmonic motion, it's a motion that will follow a general equation that looks like this. So x of t equals a, sorry, put the wrong trig function, a cosine omega t plus phi. Okay. Now, some of those quantities may kind of, sorry, some of those variables you may be like, well, what do you mean by some of this? So the first thing is amplitude. Let me move this down a little bit. Okay, so A is amplitude. That just means the maximum displacement from equilibrium, right? And we're going to look at 2 simple harmonic oscillators, the mass spring system and the pendulum. So for a mass spring system, the amplitude will be how far you pull it back. And then when you release it, it goes. And then the same thing, so for a pendulum, it's basically how far you pull it away, right, from the its equilibrium state. Phi is the phase shift. And generally here in AP Physics, even in AP Physics C, we don't worry too much about the phase shift. That just means how many radians has that function been moved. And then omega is called angular frequency. Okay, and it's very important that we talk about this because it has an equation, simply 2 pi over t, and t is what we call the period. And the period is the time to do one oscillation, right? So it's a specific time. Now what happens is you can get the rest of the simple harmonic motion equations by can be found by taking simply derivative of the position equation. So our velocity equation, if I take the derivative of that function, I'm going to get negative a omega sine, and then my what's inside, right? Omega t plus phi. And if I take the derivative again, I get the acceleration. I get negative a omega squared cosine omega t plus phi. Sorry, I ran into that graph. So these are very important equations. So these are the 3 equations that I talk about angular frequency later. Sorry. So these are the 3 equations that govern our basic simple harmonic motion. And you can see here in the graphs, that's what's traced out, right? So I can figure out my all my information from these graphs. So something to note, one thing you can see is like when your displacement graph is at a 0, velocity is at a max, right? So Vmax occurs when, so Vmax is when displacement, right, is equal to 0, okay, when it's at its equilibrium state. But then also note that the acceleration is negative at that point, right? And so kind of the same mold, our A max is negative because that's the point where it's restoring, right? It's going back, okay? Sorry, not at the 0 point. So when acceleration, sorry, so when displacement is 0, A max is equal to 0. And then when you kind of flip it and look at when you're at a max A, so when delta x equals amplitude, your V max is 0, right? And your A max is a negative maximum value, right? Because it wants to restore it back to go back to the other way. And then kind of going along, as I've already quickly talked about this, so the position equation contains the angular frequency, and the period of the simple harmonic oscillators can be determined from this point. and I'll write it down again. So it's 2 pi over t. And some other things you can see, there's a energy time graph running around here, or energy position graph that can come into play. But let's look at a quick example problem. Just simply writing these equations. So I know there's a lot of stuff here. So basically you have a 2 kilogram block sitting on a surface. It's going to be connected to a spring, which has a K value of 32 newtons per meter. The string is going to be compressed or extended. The equilibrium position is marked as x equals 0. The work is done on the block, pulling it to 0.02 meters. The block is then released and allowed to rotate, or so oscillate. And then the period of motion is 1.57 seconds. So what first thing we should do is let's figure out our omega, 2 pi over t. So it's going to be 2 pi over 1.57. All right, and that's going to give us 4.0 radians per second. Okay, so anytime you see that 1 over seconds notation, right, it has to do with the frequency in some way. So now basically all I'm going to do is I'm going to, put numbers into my equation. So x of t is going to be, my max amplitude is going to be 0.02. Cosine, and I found my omega, which is that 4. And I don't have a phase shift, so I don't have to write that in. Okay. Now, you should probably also write in the units. So this is meters, and this is radians per second. It should go there. Now, if I want to find my velocity time, well, it's going to be the first derivative of position. So I'm going to take the derivative of this one, and all I'm going to do is really, it's a chain rule, right? So if I have a cosine omega t, right? My derivative of cosine is negative sine, but I have that omega t in the inside, so I have to take the derivative of that, and that's going to be omega. So that's why an omega pops out with the other one, or with the amplitude. So what I'm going to do is I'm going to do 0.02, so negative 0.02 times 4 sine omega t. So that would be my velocity function. So all I need to do now is multiply. That's not, I wrote the wrong value. So 0.02 times 4. So it's going to be v of t equals negative 0.08. Now the unit becomes radians per second because that actually is our maximum velocity, right? Sine omega t. Okay. Oh, I know what omega is, so I can go back and plug that in. So that's going to be 4.00 radians per second t, right? Now I can do my acceleration, but remember, acceleration is the derivative of velocity. So basically I do the same thing. So 0.08 times 4. So this is going to be negative 0.32 radians per second squared cosine 4.00 radians per second t. Right? So there are my functions. And I apologize, like everything got kind of crammed here in the end, but there's my acceleration. Here's my velocity. And then there's my position. Okay. And in this video, it's just about the basics. And they may ask you after this, like, okay, what's, how fast is it moving? At what point does it reach, half the maximum speed? Okay. So you just need to kind of go back and use a little of your skills when it comes to trig, and just simply substitute or solve for what you're looking for. Okay. So in the next video, we're going to look at, we're going to start looking at the 2 specific types of oscillators, and that's going to be the mass spring system. And then in the last video, we're going to look at the pendulum.